Hello and welcome to Whites of CSE, and today we will be discussing about the process creation. I'll try to keep the video short and anyways, let's get started. So whenever a process creates another process, it's known as process creation. That's simple. In this case, we see that process A creates process B, so process A becomes a parent process and process B becomes a child process. Now this process creation in Windows is generally done using the spawn system call, and in Linux or Unix system it is done by the fork system call. Now a child process will have only one parent, whereas a parent process can have more than one child. So that gives rise to a tree-like structure, as we can see in this diagram. So this is the process tree in a Linux operating system, where init is a process with PID 1 and init has so many children, and these children have in turn their own child processes and so on, and the tree grows. So this discussion in this lecture will be mostly based on Linux operating system, because as I've seen that questions on this video is mostly based for those preparing for GATE and NET, and I've seen that the questions are mostly based on fork, that is on Linux operating system. Now let's see that how the process gets created. Now we generally call a fork. Now this is a C code, and this code will be executed only on Linux operating system. If you are trying to execute this code in Windows operating system, you will get an error. Now the ones who have Windows operating system still like to run this code and see that how this whole thing works, or you can manipulate this code. I will suggest you to try the CodeChef IDE from your internet, because in CodeChef you can run this process efficiently. Now in this case, so PID, now whenever a process calls fork, there is a return value. Now in this piece of code, that return value is collected by PID. Now as you can see that whenever the PID returns a value negative, it says that the child process could not be created, that some error has occurred. Now if that PID be 0, the child process has been created successfully. So this is what you have to remember for now. Next, when a child process has been created, now the operating system generates a copy of the parent process, which becomes a child process. Now let us see what are the attributes that are inherited by the child from the parent and what are the attributes which are not. Now generally, the child process inherits the scheduling attributes of its parents, the privileges that the parent has been granted, and the resources too. Now the resources are generally shared because this is done by the operating system to restrict a process from creating too many sub-processes. Now a child process does not inherit the process ID, of course, because a process ID uniquely identifies a process in the system, and a child process is after all a process, right? So it should have a unique ID to it. The parent, the PPID, which is also known as the parent PID. Now of course the parent PID of a process and its parent cannot be the same, because the child process will have the PID of the process which forked it, and that process, the parent process, will have the PID of that process that forked the parent process. So the PPID will be different, and whenever a signal is received, what are actions to be taken, this is also different from the child process and the parent process, and whatever be the logs that are recorded on the files, these are reset in case of the parent process and the child process. I mean, they don't have the same log on the files. So you can take a screenshot of this slide for your future reference. Okay, now moving on to the next thing is, now how do the parent and the child process execute? Now there are two options. Option number one, where the child process executes first. Now the parent process waits for the child to execute, complete the execution using the wait system call. Now the wait system call, whenever the child process is done, a parameter is passed into the wait system call that allows the parent process to obtain the exit status of the child along with the process ID of that exited child, because in case the parent has more than one processes, child processes, it will get to know that which child process has terminated. Next, now in this case, the child process uses the exec system call to continue execution. Now in exec system call, it replaces the current process with a new program, and after it is finished executing, the parent resumes the execution from the call to wait. Now the another option, which is the obvious option, where the parent and the child processes they execute concurrently. Now in this case, the child process does not call the exec system call, and the child process continues to execute as a copy of the parent, and both the processes, they run the same piece of code, but they have separate copies of data. Now let me show you an example code that illustrates this. Like, they run the same code, but the data is different for both. Now in this case, as we can see in this program, there is a variable a, integer variable a, which has been assigned a value of 10. After it has been assigned a value of 10, the calling process, the main process, it forks another process. Now this if block says that if fork equals to 0. Now this means that this if block will be executed by the child process. Else is this, whereas this block, this else part, will be executed by the parent process naturally. And this, from this line of code that does not belong to either of the block, this code is to be executed by both the parent and the child. Now let's see. Let's have a look at the program, a closer look. In this if block, what we are seeing is the value of the a will be incremented by 5 and it will be printed. In the else block, first the value of the a will be shown. After that, 25 is added to a and that value of a is also printed. In this case, the value of a is incremented by 10 and it is the output is shown by this printf statement. Now let's look at the output. Now I have, in order to make out that which a is it printing, now the value of a and its address in the if block and else block, I have explicitly mentioned that while printing those statements, so that you get to know that which process is executing which piece of code. Now the first line was value of a and its address in the else block is 10 and so and so. Now that means we are in this block and we are actually printing this statement. Alright, let me say this is print number 1. Next, the value of a and its address in the else block after incrementing with 25 is 35. Alright, so it is executing this printf statement. Okay. Now we say the value of a and its address is 45. Now clearly the parent process is executing, or we are seeing the the output from the parent process. So this piece of code is executed by the parent. So I name it as 3p. So 3p says that it was 35 and 10 is added to it and now it becomes 45. Now let's see what the child process does. The initial value of a was 10 and we see that the address in the if block is 15. Sorry, the value of a in the if block is 15. So okay, that is 15 plus, that is 10 plus 5, that is 15. Next we have this is printf number 4. Okay. Next we have the value of a is 25. So see, both the processes, that is 15 plus 10, that is 25. So see, both the processes are operating on the data, but they have their own value of A. They are outputting their own value of A, whatever be the value of A that is being manipulated by the parent process or the child process, that is not affecting each other's data. So this is a very important thing. Please take a screenshot of this, and please, if you can, please try to run this program on your own with your own data and find out what output you are getting. Now these were the output according to what I had written in this program. So I would highly recommend you, because sometimes the questions are asked based on it, that what was the value of A that is printed by the parent. Usually you don't get this line of code, but you usually ask that in these two printf statements, what is the value of A that is printed by the parent, what is the value of A that is printed by the child, and so on. All right. Okay. Now, I hope you have taken a screenshot. So I'm moving on to the next slide. Now, this is also a very important question, where you can see that some process P, say P1, say it executes fork 3 times, and the question is how many child processes are created. Now let me see how the thing works. See, there is a process P1 and it calls the first fork. This is fork number 1. So naturally a child process will be created. Let this child process be P2. Now at this point, so this is done. At this point, we have come to the second fork. Okay. Now there are 2 processes in the system, P1 and P2. So both will be executing this statement. So as a result, P2 will have a child process P3, and P1 will create another child process, that is P4. So this part is done. Now we come to the third fork. Now in this third fork, there are 4 processes in the system, P1, P2, P3 and P4. So all the 4 processes will be individually executing this line of code. So naturally, P3 will have a process, will create a subprocess P5, P4 will create a subprocess P6, P2 will create a subprocess P7, and P1 will create a child process P8. So there are total 8 processes in the system, and we will not consider this because this was the calling process or the parent process. So apart from that, we have 7 child processes which are being created by calling fork 3 times. Now there is a simple formula which says that if a fork is called for n number of times, the number of child processes in the system will be 2 to the power n minus 1. Let me check. Now in this case, the fork was called 3 times. 2 to the power 3 minus 1 should be the number of child processes in the system. So 2 to the power of 3 is 8. So this is 8 minus 1, that is equals to 7. Okay. Now moving on, so how do the child processes get terminated? Now generally, sometimes even before the child process completes, the child process is terminated. Now there are 3 situations where the child process is terminated. That is, one is when the task which is assigned to the child process is no longer needed by the system. Next is the child when exceeds the usage of the resources that has been allocated to it, that process is generally terminated. And finally, for some reason, if the parent process exits, generally the operating system does not allow a child process to get executed. So that process, all the child processes that has been created by the parent processes, is also terminated. Now this is also known as a cascading termination. That is, when the process terminates, the child processes must also be terminated. Now we'll be moving on to the last segment of this discussion, where we'll be talking about two kinds of processes. One is the zombie process. Now, what is a zombie process? Generally, when a child process terminates, before the parent process invokes a wait operation, the process becomes a zombie process. That is, when a process is terminated, all the resources that were linked to that process are revoked by the operating system, but the entry of that process along with the exit status of the process remains in the process table until the parent calls a wait operation. Now, the process, when the parent process invokes a wait operation, the exit status of the child is passed on to the parent, and then the entry of that process that has completed the execution, that is the child process, is deleted from the process table. So a process usually does not remain a zombie process for a long time for that reason. But what happens to the process where the parent terminates and does not invoke the wait operation? So in that case, the process becomes an orphan process. Now, in this orphan process, what happens in Linux operating system, that orphan process is assigned to the init, which is the first process that is created by the Linux, or rather it is actually not the first process technically, but generally we call the first living process or active process that stays in the Linux operating system is the init process with PID 1. So the orphan process is reassigned a new parent, and this time init is the new parent of that orphan process, and that now this init process, it periodically or occasionally it invokes a wait operation, and by invoking this wait, the exit status of that orphan process is passed on to init, and the process entry can be deleted from the process table by the operating system. So that was all for this video, and there is a link in the description box that takes you to a site that contains some MCQ questions regarding today's lecture, and I would highly recommend you to go through that to take that MCQ assignment, so you can see that how far you've learned. So that was all for today. Thanks for watching, and if you like this channel or if you like the lecture, please give me a thumbs up and share it with your friends. Thank you.